Hello students, welcome to IMS Gate Academy. So myself, I'm Dr. Vijay Kumar. I am going to teach you the foundation course for the engineering mechanics for the GATE aspirants 24 and 25. Now we have discussed already statistics part, and last week we have already started the dynamics as well. Okay, right, dynamics of particles we are discussing, and today's topic is collision of elastic bodies. That means impact of elastic bodies. Okay, so now part 2 of dynamics part we are studying, and today's session is impact of the bodies, right? Now let us go and start that elastic collision of bodies. So what do you mean by the collision? What do you mean by the collision? So collision is nothing but impact. Okay, collision is nothing but impact. We can call also collision is also called impact. Now let me define you what is impact, when impact is going to be occur. All right, right guys. Impact or collision, or we can call it as also collision. Impact or collision. All right, right. Now, right. So impact or collision occur when two bodies are impact each other, and for a small short period of time, then we can call it as a impact or collision. Hope you understand, guys. So when two bodies are strike together for a small period of time, then we call it as a impact or collision. All right, now take a definition. Impact occurs when two bodies strike together for a small period of time. Strike together for a small period of time. All right, guys. Right. Now here, so what is impact and whenever two bodies are strike together? That means if the bodies are strike together, see that two of my hands are act as a body together. Now when these two are going to be strike, then the impact is going to be happen. So this for a small period of time, then we are calling it as a impact or collision. Hope you understand, guys. Hope you understand. Now with the help of example, I'll explain you this. Right, see here I'm taking a right. Now another shape I'm going to take. Right, here I'm taking two bodies here. Right, say that here it is a body 1, and here it is a body 2. Right, now when these suppose say that its mass, you consider it as a say certain mass, say its mass say 15 kgs. Okay, its mass is 15 kgs, and say its mass is just 2 kgs. Okay, just 2 kgs. All right, guys. Now when these 15 mass ball or body is going to be strike the 1 minute, guys, I'll change that. When these certain velocity it is having, say v, it is also say v1 it is having, and say it is also having v2, right? So whenever these high mass ball is going to be move and strike the second 2 kg ball, then what happen? So 2 kg ball speed is going to be increased. When these strikes, this we are calling it as a collision or impact or colloidal bodies, we can call it as. All right, guys. Now here suppose say that if two equal masses are there, suppose say that if two equal masses are there, right? Now say here one of the mass, right? Yes, guys, right. Now if I see here, if you see here, then so these two bodies are having some equal masses and it is going to be move certain velocity towards this. It is also coming with the same speed. When these two are going to be strike together, then immediately what happen now? So this ball again after striking, this ball will come like this ball will move like this. Okay, so this is also one type of collision, right? When two bodies are strike together and after that they move in opposite direction. But here what happened? So this large size of the ball whenever hit this 2 kg ball, then what happen now? These 2 kg ball velocity increases and this ball is going to be backside of the 2 kg ball. I hope everybody understand what is the collision. So what is the collision? I hope everybody understood, right guys, right? Now let us move for types of impacts or types of collision. Let us move for types of impacts. Types of impacts, right? So what is mean by types of impact? What do you mean by type of impact? So how many types of impacts do we have? How many types of impacts do we have? We have two types of the impacts. Okay, so first one is central impact, or we can also call it as direct impact. Central or direct impact. Central or direct impact, or second one is oblique impact. Second one is the oblique impact, isn't it guys? All right, so first one is the central or direct impact, second one is the oblique impact. So now when we call it as a oblique impact, when we call it as a central impact, when two bodies are strike together, when we are going to see that what is that? When we call it as a central collide or central impact, when we call it as a oblique impact, I just differentiate you with the help of examples, right guys? Now guys, those who are watching this video, please see that counseling numbers are given in the below, and just enroll the IMS GATE Academy and travel with us and try to call that numbers. Then our team will come and motivate you and also giving counseling regarding the GATE point of view and what facilities and what features IMS GATE Academy provides. All these things you try to learn, okay, right? Try to utilize, right guys, right? Now let us move for the first one, central or direct impact. Central or direct impact. First one, central or direct impact. All right guys, central or direct impact. Yes, right. Now let us see this. Let us see this. What is a central or direct impact? See, so this I'll explain you with the help of a small diagram, guys. Okay, with the help of a small diagram. Right. Central or direct impact, right? Right. Now here, see guys, here I would like to highlight a small thing over here, right? Now see this line, this is a center mass of the line of two balls, so which are having certain mass, and the mass centers are going to be joined with a line. So this line we are calling it as, this line we are calling it as line of impact. This line we are calling it as line of impact, isn't it guys? Right. So the centers of, 1 minute. The centers of the two masses are joined together with a line called line of impact, isn't it? Right. Now, so if the direction of impact is aligned or is coincide with the line of impact, then we are calling it as a central or direct impact. Central or direct impact. What is that? So if the direction of the collision, so it is impacting, so the velocity line of these two bodies is collide with the or align with the line of impact, then we are calling it as a central or direct impact. Now let me show you that. right? All right, guys. Now have a look on this. Suppose say that this is a ball 1 and this is a ball 2. It's a velocity v1 and its velocity v2, you assume, right? Now these velocities are coincide with the line of impact. Then we are calling it as a central or direct impact. I hope everybody understand, right? So now here I'll write it as in a in a definition form. So have a look in this. Okay, right. Now here central or direct impact. Right. If the velocities of the bodies act on a line of impact, then we are calling it as a central or direct impact. Okay, right. Now let me write that. If velocities or if velocities of the bodies are velocities of bodies or act upon the line of impact, it is known as direct or central impact. Direct or central impact. Isn't it, guys? Direct or central impact. Now, so first one, everybody got clarity. If the line of impact and also velocities are act upon in the same line, then we are considering it as a central impact or direct impact. I hope everybody understand. I have simplified. Right. Now let us move for the second one, oblique impact. Oblique impact. Second one is a oblique impact. Second one is the oblique impact. Yes, guys, right? Now let us see that what is oblique impact. So similarly here also I'm taking the same example. Okay, have a look on this, guys. Have a look on this. Right. Now have a look on this. Have a look on this. Right. Now see, let me draw the line of impact. As we know that this is a line of impact, right? Now, so line of impact little bit I'll draw more. Okay, line of impact I'll draw a little bit more in order to understand properly. All right, guys. Right. Now, if suppose the body's velocities or not act upon the impact of line, if they are acting certain angle to the line of impact, then it is considered as a what is that? It is oblique impact. See that this is a ball 1 and this is a ball 2 and its velocity v2 and its velocity is v1, right? Now if I extend this like this, okay, now if I extend like this, now here see that the velocities of the bodies are not act upon the line of impact. So now this is called line of impact, as we already discussed. Line of impact. Yes, guys, right? Now here line of impact. So now line of impact and velocities line, if they are making certain angle to the line of impact, say it is a alpha 1 and say it is a alpha 2, then we are calling it as a oblique impact. Okay, so the velocities of the bodies are certain degrees to the line of impact, then we are calling it as a oblique impact. I hope everybody understand, right? Now let me write you the small definition for this. Okay, if velocities of bodies are certain certain angle to the line of impact, angle to a line of impact, it is considered you know, oblique impact. Oblique impact. I hope everybody understand. I hope I have simplified the what is directing the impact and what is the central impact. Yeah. I'll next week we will start. Once foundation course of engineering mechanics finish, then we will start the manufacturing also. Okay. Do not worry and keep watching and keep subscribe our channel and let updates and features of IMS Gate Academy, and also what qualities and what kind of facilities we are having and we are providing the students, you may experience. That is why the numbers are flowing on the screen. So you try to contact them. So definitely our team will come and definitely will give you the counseling in order to get the seat. Okay. Yeah, yes sir, yes electrical, I don't know your name, and I will metal science also I will teach. Okay, right. Now, so I hope I have simplified the oblique impact and also direct impact. Right. Now let us move further. Next is central impact, and most of the questions are coming from central impact only. However, I will give you the introduction of the oblique impact as well. Okay, but here first we will see the what is that? Central and direct impact problems, and then we will go for the oblique impact problems. Okay, right. Thank you. Right. First is central or direct impact. Central or direct impact. Central or direct impact. All right. Now let me go for this central or direct impact. All right. So last year you manufacturing classes at Jayanagar helped me, sir. Sure, check your rank. Okay, congratulations, and okay. So God bless you. Don't worry. So we will give you the best content, and try to enroll and subscribe our channel and experience the IMS Gate culture and IMS flavor what it is. And definitely you just spread to your friends also what your experience is there. You just spread to your juniors and your friends, and what are the kind of environment you have encounter in the IMS Gate Academy. So please support us and spread. Sure sir, thank you very much. Right. Now let's see that direct or central impact. Right. Now here, so I'm taking some examples of this. Right. Right, guys. Right. Thank you, guys. Thank you very much. Right. Now, let us see. Yeah, good evening, Atul sir. Thank you very much. Right. See, here 4 balls are there. Okay, right, which are having mass m1, and this is a mass m1, and this is a mass m2, and which is moving with the initial velocity u1. Okay, which is moving. I am assuming that which is moving with the initial velocity of u1. Right. u1. Okay. Now, which is having velocity u2. Say that. Okay. Right. It is having certain mass. Okay. Now, this is after impact. After impact. So, after impact, and here I am considering that both balls are moving in the same direction, and here I am assuming that show u1 is greater than u2. That means first ball velocity is greater than second ball velocity. So that what happened? So this first ball will come and strike this one, and then so their velocities are going to be changed after the impact or after the collision is going to be changed. All right, guys. Right. Now here I am assuming that its velocity, final velocity v1 and its velocity is v2. All right, guys. I hope everybody understand. This is a mass 1 and this is a mass 2. Now here in central impact, our objective is to find the final velocity after impact. Suppose say that two bodies are there, two balls are there. Two balls are having different masses and different initial velocities are going to be collide with each other. After the impact or after the collision, our objective is to find out the final velocities of these balls and also in which direction they are moving. I am assuming. Now here I am considering that V2 is greater than V1. That means second ball velocity is higher than first ball after the collision happen. Right. Now in order to find out the final velocities of two bodies after collision, after central impact, after central collision, then we need to use two types of principles over here. Okay, so two principles we have to use. Okay, so first one I highlight that and second one also I'll highlight that. That is one. First one is Newton's law of, sorry, first one is principle of conservation of momentum. Principle of conservation of momentum is the first principle we use to find the velocities of these two bodies. All right. So after that, second principle we use that Newton's law of restitution. So these are the two principles we use and we use to find out the magnitude and direction of the two bodies after the central collision. I hope everybody understand. Here I am taking all the direction velocities are in forward direction, right? So while you are applying the principle of conservation of momentum equation, you need to keep with the sign. Okay, now in here I am taking all the velocities are forward direction, so that I am taking it as a positive, right? Now let us move for the principle of conservation of energy. In order to find out the final velocities of the two balls after central collision, two principles we are supposed to use. That is, first one is the principle of conservation of momentum and second one is the Newton's law of restitution. All right, guys. Now let me write and elaborate that in a simple words. Right. So in order to find out V1, V2 after central collision or direct impact, after direct impact, there are two principles are used. There are two principles are used. Two principles are used. There are two principles are used. There are two principles are used. All right, guys, right? What are that? So now let me explain you the principle. First one is first principle is principle of conservation of momentum. Okay, principle of conservation of momentum. Principle of conservation of momentum. Principle of conservation of momentum. All right, guys. Right now, yeah. Good evening, sir. Good evening. Good evening. Very good evening. Thank you all. Thank you very much, Nikhil Gaurav, sir. Right now, so second one is Newton's law of restitution. Newton's law of restitution. All right. Now, by using these two principles and by using these two laws, we are going to find out the velocities of the two bodies after central or direct impact. I hope everybody understand. Right, guys. Right now, let us move further. What is the principle of conservation of momentum is stating, and how we are going to use that, and this principle how we are going to apply for this particular case. All right. Right now, here let us go for that. Principle of first one, I am writing principle of conservation of momentum. Principle of conservation of momentum. Principle of conservation of, right? Principle of conservation of momentum. Principle of conservation of momentum. Yes, guys. All right. I hope everybody understand what it is stating that actually. Okay. Now, let me explain you principle of conservation of momentum. In an isolated system, the momentum of conservation is going to be constant when no external force is acting upon. Okay, I just repeat the statement, right? Principle conservation of momentum is stating that an isolated body, the momentum is going to be constant when there is no external force is acting upon the system. All right, first I'll write the statement and then I just give you the example and how what is isolated system. And if there is no external force acting upon the isolated system, then momentum is going to be constant. That is what principle of conservation of momentum stating. All right, right. So for an isolated body, the momentum constant if no external force acting upon. If no external force acting upon. If no external force acting upon. All right. So now let us go back to our diagram. So now here, see that. So when this body, suppose if this body strike this body, so obviously some force by the second body onto the first body, isn't it, guys? Everybody okay? So up to here, everybody okay? So some force is going to be acted by this body onto this body, right? Now similarly, there will be another force by the first body which is acting upon the second body. So this force 1 is going to be, this is a force 2 acting upon body 1, force 1 acting upon the body 2. I hope everybody understand, right, guys? Now here what I'm going to tell you, what I'm going to tell you. So if these two are collide with each other or impact with each other, so that net force is going to 0. Why? Because this force resists this force. That is why there will be no net force in between the two bodies when collision occur, right? Now here what happened? I am taking these two bodies or in a system. Now here I am taking these two bodies as a system, right? Now see that these bodies I am taking a system, right? So now there will be no external force acting on this system, isn't it, guys? There will be no external force acting on the system, right? Now, so if no external force acting on the system, the moment created by this system is going to be constant. All right, the moment of this system is going to be constant. When we can say that isolated, whenever no external force is acting and when net force between the two bodies are equal, then we can say that it is an isolated system, right? For an isolated system, the momentum is going to be constant when no external force acting upon the system, right? Now these two bodies I am taking as a one system, right? So there will be no external force is acting on the system. That is why momentum, this system is going to be constant. Before impact, after impact, the momentum is going to be constant. All right, guys, right? Now I'll write the same, right? Now here the momentum. So how can we'll calculate momentum? Not an issue. Momentum before impact, the momentum before impact is equal to momentum after impact. Momentum after impact. Okay, momentum after impact, right? Now what is momentum? Momentum is nothing but mass into velocity, so that you will get the momentum. So m1 u1 plus m2 u2 is the momentum before impact, and after impact m1 v1 plus m2 v2 is the momentum, right? Now here let me write that. So let me write that. It is gonna be a right. So m1 u1 plus m2 u2 is equal to, it is gonna be a m1 v1 plus m2 v2. So I hope everybody understand. This is a very important. This is based on the principle of conservation of momentum. So principle of conservation of momentum, based on that, what happened na? So the momentum is going to be constant when there will be a no external force acting upon the system, right? Now here the momentum before impact equal to after impact. This is what is that principle of conservation of momentum. All right, guys. Now let us move for the next one. Is the second principle, Newton's law of restitution, right? Now let us go for the Newton's law of restitution. Second one is Newton's law of restitution. Newton's law of restitution. Right? Newton's law of restitution. All right, guys. Right. Now, what Newton's law of restitution is stating? Right. Now, so for a given bodies or for a given system which is in collision, we are assuming one system, two bodies are in collision. Now in that case, what happen na? So when two bodies are in collision, when two pairs of bodies in collision, then what happen na? The ratio of relative velocity after impact to the ratio of the ratio of relative velocity after impact to the relative velocity before impact is equal to constant. That is what the Newton's law of restitution stating. Okay, I hope everybody understand. I'll explain you again. So Newton's law of restitution states that when two bodies are in collision, then what happen? The ratio of relative velocity, to the ratio of relative velocity of before impact is going to be constant. Right. Now let me write that, and then we will move forward, guys. Okay, right. When two bodies are in collision, when two bodies are in collision, then the ratio of relative velocity after impact, the ratio of relative velocity after impact, right? Now to the relative velocity after impact, before impact, relative velocity before impact is constant. Before impact is constant, right? Now this is called Newton's law of restitution. This is called Newton's law of restitution. Okay, all right. Now let us move for the first one, that is this is equal to, it is relative velocity after impact. What is relative velocity after impact, right? Now go back to our diagram. Relative velocity of these bodies after impact means so higher one minus lower one. Now here we assume that V2 is greater than V1. That is why its relative velocity, final relative velocity is equal to, it is V2 minus V1. Right. Now here initial relative velocity UR is equal to, here we have considered that initial velocity of the first ball is more than the second ball. That is why here initial velocity is equal to initial relative velocity is equal to, it is U1 minus U2. I hope everybody understand. Right, guys? Right, guys? I hope everybody understand what is relative velocity. Relative velocity is nothing but difference between these two velocities. What Newton's law of restitution is stating, that when two bodies are in collision, so then the relative velocity after impact to the relative velocity before impact is going to be constant, right? Now that is what I am writing here. Now relative velocity before impact, after impact is V2 minus V1, and this is divided by U1 minus U2. Clear, everybody? I hope everybody understand, right? Now this E we are calling it as a coefficient of restitution. Okay, it is known as a coefficient of restitution. coefficient of restitution. Coefficient of restitution. Yes, guys. All right. Now let us move for E is maximum varies. E is maximum varies. No. So 0 to 1. E varies between 0 to 1. It is going to be vary 0 to 1. Yes, guys. It is varies 0 to 1. And maximum value of E. E maximum is 1. E maximum is 1. And that is for, perfectly elastic bodies E equal to 1. Perfectly elastic bodies. Perfectly elastic bodies E equal to 1. Right. Now, perfectly inelastic or perfectly plastic materials E equal to 0. So remember these points. What is E and what is the value of E and when it is going to be 0 and when it is going to be 1. So for perfectly elastic material it is 1 and perfectly plastic material it is 0. Right. Now let me write that also. Right. For perfectly plastic materials E equal to 0, right? What is perfectly plastic and what is perfectly elastic, right? Perfectly elastic means net deformation is equal to 0, right? Perfectly elastic material means here net deformation is going to be 0. Whenever they collide to each other, then so during the collision there will be a small amount of the deformation. But after the collision, if the two bodies are separated and they are after the collision they are moving in a certain direction, then if net deformation between the two bodies is 0, then we are considering it as a perfectly elastic material. I hope everybody understand, right? So next, what is perfectly plastic material? Whenever two bodies are going to be impact with each other, and after the separation, after the impact, then there will be a net deformation existing, then we are considering it as a perfectly plastic material. I hope everybody understand, right guys? So for perfectly elastic materials, it is E equal to, that means coefficient of restitution is equal to 1. For perfectly plastic materials, E equal to 0. Here net deformation exists. Now here no net deformation exists after impact, right? So if I want, you can write it as, no problem. I will write. So because it's quite important. Okay. After impact, what happened? Net deformation is exist. Net deformation exit. All right. Next, here net deformation is 0 after impact. After impact, net deformation 0. Net deformation 0. Isn't it, guys? This is what happening in this case. All right, guys. Okay. I hope everybody understand. Right? Now let us prove that. See. Let us prove that. Right. Right. Now here I would like to go for another concept, small concept only, which is related to what we have discussed so far. Okay. Right. Right. Now see suppose these two bodies are perfectly elastic. Right. These two bodies are perfectly elastic. That means after the deformation, after the impact, there will be a no deformation. Isn't it, guys? Right. Now, whenever deformation occurs, these two shapes are going to be changed. Yes. Right. Whenever no deformation occurs, these bodies remain same in their original shape. Or isn't it, guys? Right. Now, here what I'm trying to tell you, right? If deformation is 0, if net deformation is 0, then what happens? There will be a no energy consumption takes place, right? There will be a no energy consumption takes place, right? If deformation takes place, then energy is going to be consumed. Energy is going to be consumed. Clear everybody guys? Right. Now here, if I consider these two bodies are in perfectly elastic, that means there will be a no net deformation after impact. Then what happened now? So the kinetic energy of the system before impact is equal to kinetic energy of the system after impact. That is what I would like to convey. If there will be a no deformation exist after the impact, then we are considering it as a perfectly elastic collision or perfectly elastic impact. But the thing is here, if there will be a no net deformation, there will be a no change in kinetic energy before impact is equal to after impact. So the change in, that means the kinetic energy before impact equal to kinetic energy after impact for the perfectly elastic material. Clear? So that is what I would like to highlight here. Right. Now let us move high. Right. Right. For perfectly elastic materials, the net deformation perfectly elastic material, the net deformation 0 after impact. The net deformation is 0 after impact. Then there is no energy consumption. There is no energy consumption takes place. There is no energy consumption. Right. Now I will write right, kinetic energy before impact. Kinetic energy before impact is equal to, kinetic energy after impact. Right. Now let me write my kinetic energy before impact equal to after impact. That is why I'll write it is half m1 u1 square plus half m2 u2 square is equal to here half m1 v1 square plus half m2 v2 square. Clear everybody guys? I hope everybody understand. Right? This is a very important guys. Okay, so try to note it down and remember that if for perfectly elastic materials, change in energy, kinetic energy before impact equal to after impact. I hope everybody can understand this. Yes guys, understood? Now let's prove that for perfectly plastic materials E equal to 1. Okay, for perfectly plastic materials equal to 1. Right guys? Right. Now let us move for that. Now we are going to see that. So let's prove that equal to 1. Let's prove equal to 1. Let's prove equal to 1. Right. Now here, so here I have two equations. Right. First equation is what? m1 u1 is plus m2 u2 is equal to, it is m1 v1 plus m2 v2, isn't it guys? Right. Now from here I will take it as see all m's, m1s at one side, m2s at one side, you take it out. That's it first. Right. Now here I will write it is m1 u1 minus m1 v1 is equal to, it is m2 v2 minus m2 u2. Clear everybody? Yes guys, understood? Right. Now here say here you just take out m1 out. So here I'll write it is u1 minus v1 is equal to, here if I take out, it is gonna be a v2 minus u2. Clear everybody? Right. Now say it is equation number 1. Clear everybody? Right. Now here I will take so another equation. What is that equation? This equation I will take. Okay, right. Now here, so I'll go for the next slide. Next equation I'm taking, that is half m1 u1 square plus half m2 u2 square is equal to, it is going to be a half m1 v1 square plus half m2 v2 square. Clear everybody guys? I hope everybody understand, right guys? This equation I'm taking. Similarly, you do the same. Here, if I take half common, half will go, right? Now, all m1 once at one side, 2 at two side, you will take, right? Here again, m1 u1 square minus m1 v1 square I will take. Yes, is equal to, here it is m2 v2 square minus m1 v1 square I'm going to take, right? Now here, so, oh, no, here it is m2. Oh my God, I'm sorry guys, I'm so sorry. Here it is u, m2 u2 square guys, m2 u2 square. All right, right. Now here let us see, m1 you take out, such that u1 square minus, oh my God, v1 square is equal to m2 you take out such that v2 square minus u2 square, we will get it. All right. Now from here, so m1 I'll keep the same, and here I can write it is a square minus b square, na? A square minus b square. Then what happened? u1 plus v1 into u1 minus v1. Yes guys, I can write like this, na? Right. Similarly, I will write it is right. Now here m2 into, it is v2, sorry, it is u guys, v2 plus u2 into, v2 minus u2, Clear everybody? Right. Now here, according to the first equation, m1 v1 minus v1 is equal to m2 v2 minus u2, right? Here if you observe that, here m1 u1 minus v1 is equal to, it is m2 v2 u2, so that this terminology will gone, na? This terminology is going to be gone, na? Right? Right. Now here see that, so this term and this term is going to be cancel out. All right guys, right? Now have a look on this. Right. So what's remaining? u1 plus v1, right? Oh my God, 1 minute guys, I'll add this slide. Right. Now here I will get it is, what I'm going to left, what are the things left in the here in this slide? u1 plus v1 is equal to u2 v2 plus u2, right? Right. Now here u1 plus v1 is equal to v2 plus u2, right? Now bring this side, u1 minus u2 is equal to, it is v2 minus v1, right? Now here I'll write it is v2 minus v1 is divided by u1 minus u2. So this is going to be equal to 1. So what is this equation? This equation equal to E. Clear everybody? So like that we are supposed to prove. Okay, right? So don't get confused here guys. Okay, you take this m1 u1 minus v1, right? m1 u1 minus v1 is equal to what is that? m2 v2 minus u2, right? Now here see that m2 v2 minus u2, both are equal, na? According to the first, from 1 you can write, if you want, from 1 you can write it as like this. Okay, no problem at all. Okay, right. Now here we have proved that equal to 1. Okay, now here we have two special cases. So after these two special cases, and we will move forward for the solving questions. Okay, now in this collision, in direct impact or central impact, we have two special cases. Now let us go for that two special cases. Okay, first case 1. First is case 1. Right. What's case 1 special case is stating? Okay. Okay, right. If there is a perfectly plastic collision takes place between the two bodies. If there is a perfectly plastic collision takes place between the two rotating balls, that means two balls or two bodies, then what happen na? So after the collision, the two bodies are together and move with the same velocity. Right, guys? I hope everybody understand. If the perfect plastic collision or impact takes place between the two bodies, then after the collision or after the impact, what happened? So the two bodies are together. They used to move in a same direction with the same velocity. Is come under special case 1. Okay, right. Now here, so first I'll write the statement. If two bodies, if perfectly plastic collision takes place between two bodies, then after impact, two bodies are together, they used to move with the same velocity. Two bodies are move together with the same velocity. All right, now I will show you guys. So with the help of a diagram, I'll show you guys. Don't worry. Right. Now here, if suppose these are the two bodies, right? So after impact, then what happened now? These two bodies are right. Now here what I'm considering, perfectly elastic collision, perfectly plastic collision, guys. Perfectly plastic collision, right? Now here it is U1 and its mass is M1 and its mass is M2, right? Here it is U2, right? Now here, so after impact, now here I'm assuming that which type of impact it is? Perfectly plastic. That means perfectly plastic. That means what happened? So net deformation is going to be existed. That is why the two bodies are together. They used to move with the same velocity. That means here V1 is equal to V2 is equal to V only. All right. So that is what I would like to highlight, right? If it is a perfectly plastic collision takes place between the two bodies, then the two bodies after impact together they used to move. So together they are going to be travel. So that is what the first special case I am going to give you in the central or direct impact. I hope everybody understand. Right? Now see, we will prove also. V1 equal to V2 equal to V. How can we prove that? What is that? Perfectly plastic materials E equal to 0, right? Now let's take that equation. E is equal to, it is V2 minus V1 is divided by U1 minus U2, isn't it? Right? Now for perfectly plastic materials, it is equal to 0 for perfectly plastic materials. For perfectly plastic materials equal to 0. I hope everybody understand. I hope everybody understand, guys. I hope everybody understand. Now here, let us move for the proving that. So E equal to 0 na, such that why E here not equal. So this is equal to 0, right? Such that what happen? Simple, one step only, right? What it is? So V2 minus V1 is equal to 0, right? Such that V2 is equal to V1, that is equal to V. That is what I just wanted to prove that. That means if it is a perfectly plastic collision, then final velocity of the two bodies is same. That is what I would like to highlight, guys. That's it. That's it. Hope you understand, guys. Hope you understand, right? So now if you like the video, then you like the click button and try to, so some floating, our institute floating number is floating over there, and join with us, and so you just enjoy the flavor of IMS GATE Academy. All right. Right. Now let us prove that second case. Second case. What second case is stating that? What second state? Case 2. Case 2. All right. What's the case 2? Right. So now let me go for the second case. In the second case, what happened? In the second case, what happened? If there is a perfectly elastic collision takes place between the two bodies of equal masses, okay, if there is a perfectly elastic collision takes place between the two equal masses of the bodies, then after impact, what happened? The velocities of the two bodies are going to be interchanged. The velocities of the two bodies after the impact are going to be interchanged, right? Now let me write the statement, and then we will prove that with the help of our equations. Okay, we have a momentum equations, we have a law of restitution, and we have a kinetic energy equation. By using that, we can prove that. So whenever the perfectly elastic collision takes place between the two bodies, then what happened? So the velocities of the two bodies are going to be interchanged whenever the mass of the two bodies are going to be equal. Right, guys? Right? Let's go for and try to solve this. Right. If perfectly elastic collision, a perfectly elastic collision takes place between two bodies, a perfectly elastic collision takes place between two bodies of equal masses, then the velocities of bodies interchanged, after impact. All right, this is what the second case. All right, guys, now let us go and prove this one. Let us go and prove this one, right? See that? So with the help of examples, again we will see that, guys. Okay, right here one body I'm taking and another body which are having equal masses, right? Now after impact, right? After impact, so the impact is perfectly elastic. That means net deformation is 0. Perfectly elastic, net deformation is 0. All right, guys, right? Now here, so I'm taking this velocity, say u1, and this velocity, say u2. But here the bodies of masses equal. That is, here it is m, here also it is M, guys. Okay, here it is M, here also it is M, right? Now what type of collision here? Perfectly elastic, right? Now after impact, okay, right. What type of collision it is? Perfectly elastic, isn't it, guys? Perfectly elastic collision takes place over here, right? Now here what is the statement is saying that whenever two bodies of equal masses or impacted to or perfectly elastic collision takes place between these two equal masses of bodies, then so what happen now? The velocities of the two bodies are going to be interchanged after impact. Now here the velocities are going to be interchanged. Suppose say that, so for in order to understand that, say this is a first ball and say it is a second ball, right? Now here it is a first ball and here it is a second ball, right? Now the masses are going to be equal now, so this mass equal to this mass, right? Now here what happened now? So now if perfectly elastic collision takes place between the two equal masses of the bodies, then the velocities are going to be interchanged after the impact. Clear? Hope you understand, guys. Hope you understand, right? Now let us see what are the interchange. If the velocities are interchanged, this velocity become u2, this velocity become u1, right? Isn't it, guys? Velocities are going to be interchanged now. So first velocity is equal to second velocity equal to first velocity, right? Now can we prove that? Let us prove that. So now take momentum equation, guys. Take momentum equation here. Take momentum equation. How can we write? So m1 be u1. So there will be a no m1, right? So there will be a no m1. So m1 u1 in place of m is constant, right? mu1 plus mu2 is equal to mv1 plus mv2. Momentum equation, right? From there m will get cancelled now. I am going to get u1 plus u2 is equal to, it is going to be a v1 plus v2. All right, guys, v1 plus v2. Say it is a equation number 1. Say it is a equation number 1. Yes, guys, it is a equation number 1. I hope everybody understand, right? Now let's take that for perfectly elastic materials. Take that coefficient of restitution. For perfectly plastic materials, what is the coefficient of restitution? Coefficient of restitution equal to 1 na, perfectly elastic material, right? So perfectly elastic collision then equal to 1, Now let's take that equation also. Oh my god. Right. Now for perfectly elastic collision equal to 1. For perfectly elastic collision equal to 1. What is E? Equal to, we know that V2 minus V1 is divided by U1 minus U2 na. So that is equal to 1, right? Now, so I'll write this equation, V2 minus V1 is equal to, it is going to be a U1 plus U2. I'll take this equation is a number 2, right? So now write the first and second equation together. Write the first equation and second equation together, right? Now I will take another slide. Right, here first equation is, what is the first equation, right? So u1 plus u2 is equal to v1 plus v2. u1 plus u2 is equal to v1 plus v2. Say it is equation number 1, right? So now what we got in the second equation, v2 minus v1 is equal to v2 minus v1 is equal to, so u1 minus u2, isn't it, guys? Okay, this is a second equation, right? Now here see that here, guys, if I interchange this first equation, how can I write? So I can write it is u1 minus v1 is equal to v2 minus u2, isn't it, guys? Say it is equation number 1. I just interchanged this, right? Now if we add, then what you are going to get, right? So v1, if we add that, so this is going to be, u2 v2, 1 minute, guys. No need to do this. No need to do this, guys. No need to do this. Okay, not required. Here only we can cancel that. Right? Simply I'll write it as modified equation. Right? Now here, so V1 plus V2 is equal to U1 plus U2. Right? This is the first equation. I just take the U's and V's at one side. That's it. Okay. So right now here you just add this. You just add this. If we add, so these two terminologies will gone, right? So that you are going to get it is V2 plus U2, and so U2 will get cancelled such that it you are going to get it is here U1 to U1. All right. So V2 plus U2 is equal to, it is going to be a, so no 2 V2. So V2 it is. So V2 2V2. 1 minute, guys. 1 minute. The small letters are going to be confused. That's it. I used to write what is that? V and U at similar passion. That is a confusion here. So nothing that like that. Okay, right. Now here, so V1 will get cancelled. It is gonna be a 2V2, and it is gonna be a so U1. So 2U1, such that you are going to get it is V2 is equal to U1. Okay, V2 is equal to U1. Now let us go and see that. So here V2 equal to 1. So actually it is V1 and it is V2. So V2 equal to U1 we have proved. V2 equal to U1 we have proved. Now we have to prove that V1 is equal to V2. V1 is equal to U2 we have to prove. Now let us here we have added these two equations, right? You just subscribe. That means minus these two equations, one and second equation. Now let me write that V1 minus V2 equal to U1 minus U2 is a first equation. I'll write V1 plus V2 is equal to U1 plus U2. V1 plus V2 is equal to U1 plus U2. All right. Say it is a first equation. Right. Now second equation. What is that? V2 minus V1 is equal to V2 minus V1 is equal to U1 minus U2. Isn't it? Oh no. U1 minus U2, right? So now minus this equation such that it is going to be a minus, it is going to be a plus, it is minus, it is plus, right? Now here what happened? So here minus V2 plus V2, these two will get cancelled now, right? Now these two is going to be cancelled, right? Now so U1, so U2, so this is a U1 minus U1 minus U1. This also will get cancelled, right? Now here what we are going to get? Let me write the rest of the things here. 2V1 is equal to 2U2, such that V1 is equal to U2. Okay, right? So now here we proved that V1 is equal to U2 and also V2 is equal to U1 by using the two equations. Only. What are that? So here we have taken E equation. So we have taken U equation and momentum equation. Momentum equation, you will get one equation, right? After that, so this equation we will get second equation. That is by using U. Now, if these two equation, one time you add, you will get V2 equal to U1, and second time you just minus between 1 and 2, so that you are going to get V1 equal to U2. Okay. Now this is what I have proved. So V1 equal to U2 I have proved, and V2 equal to U1 I have proved. So now here the special case is validated and proved that. What is that? If perfectly elastic collision takes place between the two bodies of equal masses, then their velocities are going to be interchanged after the collision, right? I hope everybody understand, guys. I hope everybody understand, right? Now here go back to that. So today what we have discussed, law of momentum conservation and also Newton's law of restitution, and in that two special cases we have seen, and by using all this we need to solve the problems. So okay, these are the very basics of the collision. All right, guys, now let us go for solve one question related to this, guys. Right, have a look on this question. Have a look on this question, guys. Have a look on this. So try to solve by using this. So I will give you 1 minute time. Try to solve, guys. Yeah. Good evening, Shravani. Very good evening. Thank you for watching. So thank you for watching, session, right? Now, previously we had been discussed and we have solved so many, right? Now let us solve this problem. Have you solved? So I will solve you. Okay, I will solve you. Let me read the question. So what is the question is given? A ball of mass 2 kgs moving with a 2 meters per second collides centrally. Central collision here, guys. Central collision. So central collision with another ball of mass 4 kg moving with a 3 meters per second. Okay, so in opposite direction, both are in opposite direction. Two balls are there. One ball is 2 kgs, another ball is 4 kgs, which are having their own velocities, and then they are moving each other opposite direction, right? If the coefficient of restitution is 0.5, find the velocities of both balls after the impact. Both balls after the impact, right, guys? Now let us go for first you draw the diagram so that you will be able to understand properly, guys. Okay, so first you try to draw the ball and then you will be able to understand, right? Now here one ball is there, right? Right. So another ball, right? Now say impact is going to be happen. What kind of impact it is, guys? What kind of impact it is? Impact is central impact. Central impact. All right. Now here let me fit the data. What is the data here? A ball of 2 kg mass. Okay, this is 2 kg. Right. Now, so its velocity is v1 u1, sorry, u1, initial velocity only, na, before impact it is initial velocity only. So right, now u1 is equal to how much they gave? So it is 2 meters per second, right? So next, another body is velocity u2 is equal to, it is 3 meters per second. All right, now let us see that. Right, now here, so its weight is 4 kg. Its weight is 4 kg. Both are in opposite direction. Right, now, so this is moving in this direction and this is moving in this direction. All right, guys. Right, now after the collision, right? Now let me draw the balls again. After the collision. Right, now after the collision, what's its velocities? Okay, we have to find this velocities, right? Now here I'm going to take that both are in same direction. Okay, both are in same direction. I'm assuming that, so v1 is having in the same direction, v2 also playing in the same direction, right? Now here these masses are constant, that means this mass is also, 1 minute, guys, so let me draw this. So this is also 2 kg and this is 4 kg, right, guys? Now here I'm assuming that both are in the same direction, right? If I'm assuming like that and I'm going to solve the question. If I got negative of any one, then its direction is going to be opposite. That's it. Very simple, guys. Very simple. Okay. So what I'm trying to tell you here, I'm assuming that both balls after the impact, so are going to be moving in the same direction, such that I'm considering it as a positive, and in the forward direction they are moving. I'm assuming I'm going to solve the question. If I got V1 or V2, anyone I got minus, then its direction is going to be opposite. So my assumption is wrong, then I'll change the direction, right? Now, otherwise you consider that both are in opposite direction, both are in the backward direction, and go and solve the problem. So you will get positive or negative, then you change the direction. That's it, guys. That's it. So no intention at all. Okay. Now, so one more thing they gave that E equal to how much they gave? E equal to 0.5. Equal to 0.5, right? Now, by using this equation, by using this data, we have to find V1 and V2. Hope you understand, guys. Hope you understand, right? Now, let us solve the first. We'll write momentum equation, right? First, we will write momentum equation. M1 U1 plus M2 U2 is equal to M1 V1 plus M2 V2. Isn't it, guys? M1 U1 plus M2 U2 is equal to M1 V1 plus M2 V2, right? M1 we know na. What is the M1? 2 kg, 4 kg, and 2 into 2 and 4 into 3, right? So, right now here 2 into 2 plus 4 into 3 is equal to, right? Now we don't know na, mass 1 we know 2 kg, and V1 we know, we don't know. Now mass 4 kg, and it is V2. Isn't it, guys? Right? It is going to be a 4 plus 12 is equal to 2 V1 plus 4 V2 I'm going to get, right? So finally, I'll write this equation. So 2 to 4 and 12. It is going to be a 16 is equal to 2 V1 plus 4 V2, right? So if you take 2 out, such that what happen, I'll write it is V1 plus 2 V2 is equal to, it is going to be a 8. Say it is equation number 1. Yes, guys. I know the value of M1, M2 and U1, U2. So I substituted that and I develop equation in terms of V1 and V2. So this is a one question. Okay, right. Now let us move for the E equal to, we will write. Oh my God. 1 minute, guys. Right. Now E equal to, they gave in the problem na, E equal to 0.5. Right. Right. Let's write the E equation. V2 minus V1 is divided by U1 minus U2 is equal to 0.5. All right. Now let us write this. V2 minus V1 is equal to, it is going to be a 0.5 into U1 minus U2. All right. So now what is U1? U1 is 2 and U2 is 3. U1 is 2, 0.5 into, it is going to be a U1 is 2 minus U2 is 3, such that it is going to be a minus 1 minus 0.5, right? That is V2 minus V1 is equal to minus 0.5. Say it is equation number 2. Yes, guys. We got two equations. By using the momentum equation, I got one equation in V1 and V2, and I got another equation in V1 and V2 in another equation by using the law of, coefficient of restitution, right? Now by solving these two equations, so that we can find the V1 and V2 now. By using this equation, we can find V1 and V2, right? Now let's draw. First, I'll write the V1 plus 2 V2 equal to 8. V1 plus 2 V2 is equal to 8, right? Say it is equation number 1, right? Similarly, V2 minus V1 is equal to 0.5. V2 minus V1 is equal to minus 0.5. Say it is equation number 2. Add these two, right? Now if we add, so these will get cancelled. All right. Now if we add, such that it is going to be a minus only, right? Now here I'll write it is these two are pluses only na, right? Such that I am going to get it is 3V2 is equal to, it is going to be a 7.5, right? Now V2 is equal to 7.5 is divided by 3 such that I am going to get my V2, I am going to get my V2, you know, 0.5, 0.5, no, 2 only, no. So just calculate that. It is going to be a right. Now let me see that it is going to be a 7.5 is divided by 3, 2.5, 2.5 meters per second, right. Now substitute any one equation, that is V2 minus V1 is equal to minus 0.5 such that I am going to get V2 I know na. So right here I will write it is 2.5 minus V2 V1 sorry 2.5 into V1 is equal to minus 0.5, right. If I take this side such that what happen na, V1 is equal to, it is going to be a, so 3 meters per second will come, 3 meters per second will come. All I got positive na. So that is why here my assumption is correct. My assumption is correct. I hope everybody understand, guys. I hope everybody understand. Like that you are supposed to solve the questions related to this. Okay, right. Now here let us go and introduce, you know, so our toppers and IMS Gate Academy futures as well. Okay, right. Now here guys, join with us. We will give you the best content, and you know, so we release the updated books in soon, and we have a lot 20 to 30 theory and exercise books as well, and try to appear our chapter wise test and enroll in our zero free program. Everything will be in the IMS Gate Academy website. If you go and watch, and now let us introduce that my our gate toppers in the 2023 All India rank 3 in mechanical, All India 4 in instrumentation, All India 4 in CS, All India 4 in, you know, production and industrial. All India rank of ES is 7, right. So mechanical 7th rank, and All India mechanical 9th rank, production 10th rank, and you know, All India 17th rank in ECE, and EEE 15th rank, and All India 19th rank in CE. Okay, right. So these are all our, you know, our students, and which are enrolled with us, and they joined with us, and you know, they got success with our help, and we motivated you. You know, if you are very not confident, we'll have a mentorship program of so you may directly contact with the faculty, so in order to get the enhance the confidence levels. Okay, right. So now here thank you IMS Gate Academy, thank you very much for all of your patient listen. Thank you all.